Welcome to the Explainer. Today we are cracking a case, the case of the most important element you've probably never even thought about, carbon. It's the silent superstar that's behind, well, pretty much everything.
All right, let's just jump right in because we're starting with a real puzzle. Think about it. Carbon is in your food, it's in your clothes, it's in, well, you. It's the literal backbone of all life on Earth. And yet, if you look at the planet as a whole, there's almost none of it. So what's the deal? How can it be the star of the show and, at the same time, be so incredibly rare?
And that right there, that's what we're calling the carbon paradox. It's the big mystery we're here to solve. So let's start by looking at the actual numbers. Okay, take a look at these numbers. They are shockingly small. I mean, just 0.02% of the Earth's crust, a tiny 0.03% of the atmosphere. In the grand scheme of things, carbon is barely there. So how in the world does it manage to build the entire world of biology from such a tiny supply? Well, it turns out it has a few secrets. All right, secret number one. It's all about its personality. You see, carbon isn't an element that takes or gives. It's a collaborator. It's a sharer. And this all comes down to one thing, the way it forms bonds with other atoms. And this is where things get really interesting. See, most elements form what we call ionic bonds. They kind of just steal or give away their electrons. That creates these super strong forces, which means high melting points, and they can conduct electricity. But look at carbon compounds. They're the total opposite. Low melting points, terrible conductors. That's a huge clue that something very different is going on with its bond.
So here's the why. A carbon atom has 4 electrons in its outer shell, but it really wants 8 to feel stable and complete. Now, trying to grab 4 more electrons, that's way too much for its little nucleus to handle. And losing 4, that would take an insane amount of energy. So, what does it do? It comes up with this brilliant solution. It shares. This whole sharing strategy is called a covalent bond, and it is the absolute foundation of everything that makes carbon so special.
And get this sharing thing isn't just a one-trick pony. Carbon can share 1 pair of electrons, making a single bond, or it can share 2 pairs, forming a double bond. It can even share 3 pairs for a triple bond. This flexibility is what gives it so much power and versatility.
Okay, so we've established that carbon is an expert at sharing. But sharing electrons is one thing. What carbon actually builds with those shared connections, well, that's where the real magic happens.
This brings us to secret number 2. Carbon has this genuine superpower called catenation. Basically, it's incredibly good at linking up with other carbon atoms to form these long, super stable chains and really complex structures. Yeah, a few other elements can kind of do this, but nobody, and I mean nobody, comes close to carbon. The bond between 2 carbon atoms is just rock solid.
And here's why it's so good at it. Remember those 4 outer electrons it likes to share? Well, that means it can form 4 bonds at once, a property we call tetravalency. Think of it like having 4 hands. It can build up, down, left, and right all at the same time. This makes it the ultimate molecular architect, creating these huge, complex 3D structures that are absolutely essential for life.
If you want the perfect example of how much this matters, look no further than this. Diamond and graphite. Both are 100% pure carbon, nothing else. But in a diamond, every single carbon atom is locked into a rigid grid with 4 others, making it the hardest thing we know. In graphite, the atoms are arranged in these flat sheets that slide right past each other. That's why it's soft enough to write with. It's the exact same element, but with completely different properties, all because of how it's built. This building skill is so sophisticated, carbon can pull off another amazing trick. It can take the exact same set of atoms, the same recipe, and arrange them in different ways to create totally different molecules. We call these structural isomers. Same formula on paper, but in reality, they're unique compounds with their own special properties. It's pretty wild.
Okay, on to our third and final secret. Carbon isn't just good at bonding with itself. It's also a total socialite. It's extremely friendly and loves forming strong connections with a whole bunch of other elements. Because it's a pretty small atom and its covalent bonds are so strong, it can form incredibly stable compounds with elements like oxygen, hydrogen, nitrogen, you name it. And this just opens up a nearly infinite library of possible molecules it can create.
And when these other atoms attach to a carbon chain, they act like little accessories that completely change the molecule's identity. We call them functional groups. Slap an OH group on there and boom, you've got an alcohol. Add a COOH group and now it's an acid, like the stuff in vinegar.
It's how carbon creates this whole universe of different chemicals, each one with a specific job to do.
Okay, so we've got the secrets: sharing, building, and socializing. Let's see how they all come together in things you and I use every single day.
So it probably won't surprise you that the energy that powers our world is pretty much all about carbon. The fuels we use, they're mostly just compounds of carbon and hydrogen, which we call hydrocarbons. The natural gas that might heat your home, that's mostly methane. When you burn these, they release a ton of energy. And it's cool, right? The type of flame you get can actually tell you about the kinds of carbon bonds inside the fuel.
Even something as basic as washing your hands. That's a carbon chemistry magic show happening right in your sink. You see, soap molecules are basically these long carbon chains, but they have a very special design. One end absolutely loves water, and the other end loves oil and grease.
So here's how the trick works. Those oil-loving tails dive in and grab onto all the grease and dirt. At the same time, the water-loving heads stick out, facing the water. They form this tiny little sphere called a micelle, with all the dirt trapped safely inside. The outside of that sphere is totally water-friendly, so when you rinse, the water just grabs the whole package and washes it right down the drain. It's absolutely brilliant.
Which brings us all the way back to the beginning. After uncovering all these secrets, we can finally answer that paradox we started with. Why is carbon, this element that's so incredibly rare, the foundation of, well, everything?
It all comes down to a perfect storm of three key traits. First, it's tetravalency. That ability to form 4 bonds lets it build complex 3D molecules. Second, catenation. Its unique skill for linking to itself creates the stable backbones for huge things like DNA. And finally, its versatility. The way it bonds with so many other elements creates the endless variety that life's complex chemistry demands. There is literally no other element that can do all of these things so well. And that's it. That's why carbon is the ultimate undercover superstar. The quiet architect that, even though there's not much of it around, has built our entire living world. So the next time you look around, just think about that invisible scaffolding holding it all together. Makes you wonder what else is hiding in plain sight.